All right, so again, your final exam is going to start with chapter 4, which is where we started the semester at, and it goes up until chapter, what did we just finish? Thank you. Obviously jumping around a little bit. What did you just say? No, 9 with 10 too, yes. But we jumped around, right? We did a little bit from this book, we did a little bit from the Brown book. So everything that was covered within the semester will be overall covered on the final exam, but in different ways. You will not have a calculator on your final exam at all. So it's not like you get part calculator, part not. So any kind of graphing thing, you wouldn't have it, okay? Which means that certain topics are not part of it. Like obviously we can't do lob sines and lob cosines because those required calculators, stuff like that, okay? But we're going to start at the beginning and work our way through. So this is rational functions and conics. Rational functions was the beginning of chapter 4. These are the ones that have asymptotes, okay? And at the beginning of these, we found the domain, the vertical asymptotes, the horizontal asymptotes, and the slant asymptotes of these rational functions. So that's what we're going to review. To find the domain of a rational function, and this means that there's a variable in the denominator. That's what a rational function is, okay? And the graphs have asymptotes. So the domain, we would set the denominator not equal to 0. So the domain is all real numbers except what would make my function undefined, and what makes the function undefined would be the value that makes your denominator 0. So if you just simply look at A, then I'm going to look at the bottom. We did do things where we had to simplify and cancel out with holes. That's not on your final, okay? I'm going to look at the bottom, and I'm going to factor out the x. And then I'm going to say neither of these can equal 0. So x cannot equal 0, and x cannot equal -5. We did these in interval notation and also in like just written notation, which is what this is multiple choice, which is what it would be. It would say x where x cannot equal -5 and x cannot equal 0. That's what your answer's format would be in. Yep. Yep.
Wait, so we're not putting it into like parentheses?
You don't need to put that one in interval notation, no.
So like you just do the like weird bracket looking thing?
Well, that's read as x where, that's what the straight line, x cannot equal -5 or 0. Okay, so I'm going to leave B, but you're going to go back to it later. Okay, so we're going to do at least one of each kind, and if there's time, we'll go back to it later. Now we go vertical asymptotes. And the way you find the vertical asymptotes is you set the denominator equal to 0. So it is the opposite of the domain. And these will all be x equals a number. They have to be an equation. And specifically an x equals because that would be a vertical line. Yep.
How can we tell if it's vertical or if it's like to set it equal to 0 or to not set it equal to 0?
What would be the other option? You mean horizontal? We're going to get to that next. Is that what you mean?
Yeah.
So it will literally say find the vertical asymptotes. To find the vertical asymptotes, I would set my denominator equal to 0. I would try to factor it. This is the difference of two squares. It would factor to 2x. 2x, one gets a +5 and one gets a -5. And then I'd split and solve those. 2x equals -5, x equals -5/2. And 2x equals +5, x equals +5/2. So there are two asymptotes here. X equals -5/2 and x equals 5/2. Again, you're going to go back to B. Yep.
So for A, our answer is just like the answer in the parentheses.
Okay, then came horizontal asymptotes, and horizontal asymptotes had 3 cases, and it was based on the exponents. If the exponent, so we called the exponent in the top, so this would be xn for numerator, xn m for denominator, okay? If they were, so we start with if n is less than m, then y equals 0 is your horizontal asymptote. If the one in the top is less than the one in the bottom. If they are equal, then we did y equals the leading coefficient of the numerator over the leading coefficient of the denominator. The leading coefficient being the number on the front of the term that has the highest exponent. And the third option is if it is greater than m, and in that case there is no horizontal asymptote. So these I'll do all three with you because there's one of each case. So if you look at A, what's the highest exponent in the numerator? 1 is the highest exponent in the numerator. What's the highest exponent in the denominator? 2. So what's that relationship? It's less than, which means y equals 0 is your horizontal asymptote. Go to B. Highest exponent in the top? 2 in the bottom? What's true there? Same. So this is leading coefficient. The leading coefficient in the top is 2. Leading coefficient in the bottom? 1. So it would be y equals 2 over 1, or y equals 2. Then go to C. Highest exponent in the top? 2. Highest exponent in the bottom? Is there an x there? No. So it would be 0, right? If there was an x here, it would be to the 0. What's the relationship there? It's bigger this time, which means no horizontal asymptote. And the third kind of asymptote was the slant asymptote. And this happens when n is 1 more than n. So when the exponent in the top is 1 more than the bottom. You cannot have both a slant and a horizontal. Because if it's more, there's no horizontal. It doesn't mean there's always a slant, but it means that there's no horizontal. If it's 1 more, then there's a slant. And then to find these, we divide the numerator by the denominator. And we ignore the remainder. God bless you. So if you look at the one that's there, the exponent in the top is 2, the one in the bottom is 1, that is 1 more. And you can divide 2 ways. I can do long division, where I take the top, x squared minus 5x plus 4, and divide it by the bottom. And it's first into first. So what would I have to multiply x by to get x squared? X, and I'm going to multiply it times both the things on the outside. So x squared minus 6x, and then we change our signs and add. And what do I have to multiply x by to get to x? 1. I multiply it times both. As long as that first one cancels, I ignore the remainder. It doesn't even matter what's there. What's at the top gets set equal to y, and that's my slant asymptote. Yep. Not if you do it right. Yeah. You also, because the divisor is not an x squared, right? It's just the 2 terms x plus or minus something. You could also do synthetic. For synthetic, we write out the coefficients on all the terms in my numerator. So it'd be 1 -5, and 4. We draw that nice long box, and sometimes they kick it back the other way. And I put the opposite of what follows x in my divisor. So it'd be a +6. I bring down the 1. I multiply by 6 and put it in the next column and add it. I multiply by what's on the outside, put it in the next column, and I don't even need to add it. That last one's the remainder that I would have ignored. Then the constant, then the x, and I'd still get y = x + 1. So you could have done it either way, long division or synthetic. Questions on domain, vertical asymptote, horizontal asymptote, or slant asymptote? Yeah. Okay, then came parabolas, ellipses, and hyperbolas. So this was 4-3. Actually, the standard form, I think, was 4-4. When we get to the bottom, I'll write that there. This box was given to you on your test. It will be given to you again on your final. But you had to know how to use it. So if you remember parabolas, right? Parabolas only had one squared term. Either the x was squared or the y was squared. In standard form, that was the term that was by itself, so there's nothing in front of it. And then on the other side was your 4p. If your x is squared, then your parabola is pointing up or down. If it's a +4p, it points up. If it's a -4p, it points down. If it's a y squared with a +4p, it points to the right, -4p, and it points to the left. And p is the distance from the vertex to the focus and the vertex to the directrix. The focus falls inside the parabola. The directrix falls the opposite direction. So if it points up, you've got a focus inside and you've got a directrix on the opposite direction. And the focus is a coordinate point. And the directrix is an equation. If it's horizontal, it's y equals. If it's vertical, it's x equals. All right, so let's skip to parabolas and then we'll go back up to ellipses. So the example here says graph the parabola, y - 3 squared = 24 times x + 1. What do you know just by looking at the equation? It's pointing to the left because it's a y squared and a +4p. So I know it points left. What's your vertex? Switch it. Opposite of what follows the x, right? So -1, opposite of what follows y, so +3. So I go -1, +3, and I plot a point. Yep. Oh, sorry, it points to the right. No. It does. It points to the right. Let me go back. It points to the right because it's a +4p. Vertex is still -1, 3. If 4p is positive, it points right or up. If 4p is negative, it points left or down. Because this is multiple choice, you need to be smart about it too. Like if this is multiple choice and you look at your choices and there's only one that points to the right, you're done. You don't even have to find anything else. If it was multiple choice and there's 2 that point to the right, now you've narrowed it down to those 2, okay? Now it might say like graph and find the focus or graph and find the directrix, and then that would be the other part. That would be the differentiation. The wide and narrow is not going to affect you. So now I know 4p = 24, so p would equal 6, which means to the left of my vertex, 6. So I'd be back at -7 is my directrix. So x equals -7 is the directrix. And to the right 6 places, so from -1 to the right would be 6, it would be 5. And that 5, 3 is your focus. So the question might say graph and find the focus. It'd say graph and find the directrix. It just might say find the directrix or the focus.
Wait, how do you know your focus?
It's so when you solve for P, you're going to go that many spaces to the right from your vertex. Yep.
How do you know how wide to make a tablet?
It doesn't really matter at this point. You would have to plot a point to know how wide or narrow because it's not in standard form, but I mean it's on vertex form. Okay, B, find the standard form of the equation. So now we're working backwards. Sarah.
I have a quick question about this last one.
Uh-huh.
So how do you know how, like, do you just, like, eyeball the parabola, like, draw it, like, however, or do you have to, like, figure out, like, the actual...
You mean the narrow or wide?
Yeah, like,
So it's not going to matter the narrow or wide on your multiple choice.
Okay.
If you wanted to get an exact one, you'd have to plot points.
Okay.
Yeah. All right, find the standard form of the equation. Now we're working backwards. So if I had a focus, so we will give you a piece of graphing paper for questions like these if you want to keep that in mind. But if I had to draw it, I would go focus is 4, 0, so that's my focus. And I would go directrix is x equals -4. That's my directrix. Already you know what direction is it going to face? To the right, which means which variable is going to be squared? The y. So this is a y minus k squared equals 4px minus h situation. I know this because it has to go around the focus and away from the directrix. Where is the vertex?
0, 0.
0, 0. I have to find the point halfway between those two. So I can either like use the midpoint formula, pick a point on the directrix and find the midpoint formula, or you could literally count. With a graph paper, you could literally count. So my vertex is 0, 0, which means it's a y squared equals, I'm going to plug in the p in a second, but times x. There's no h or k. And to find P, I can count in either direction. To the right, 1, 2, 3, 4, or to the left, 1, 2, 3, 4. P is 4. So my equation would be y squared equals 16x.
Wait, so how do we know that the vertex is 0, 0?
Because it's halfway between the focus and the directrix.
Okay.
I would say be really careful with questions like these. Obviously, multiple choice is helpful, but it just as easily to pick something that said x squared minus 16 or equals 16y, a careless mistake like that could cost you all the points. Questions on parabolas? Yeah.
Do we leave the answer as y squared?
Mhm. No, you leave it as y squared. All right, then came ellipses. So I'm going to go back up to the chart because I'll like keep referencing this chart so that you can hopefully picture it when you go to take your test. With an ellipse, there are two, vertical or horizontal, and we know it's an ellipse because it has a plus in between. That's the differentiation between ellipse and hyperbola. And in an ellipse, the A is the bigger number. It has nothing to do with its order. If the bigger number is under the X, then this is a horizontal ellipse, which means that it is wider than it is tall. If the A is under the Y, so if the bigger denominator is under the Y, then it's vertical, which means that it is taller than it is wide. My HK is my center. The A is the distance from center to vertices. The B is the distance from the center to the co-vertices. And the C is the distance from the center to the foci. God bless you. God bless you. God bless you. God bless you. You're welcome. For ellipses, the relationship between those three letters is c squared equals a squared minus b squared. Remember that the sign in between the a and the b is opposite the sign of your standard equation. So because it's an ellipse, it was positive. The c squared relationship is minus. The main vertices are the ones that are on the major axis. So let me highlight this in different colors. The actual vertices would be on the major axis here and here. The co-vertices go on the minor axis or the shorter axis there and there. And the foci are on the major axis inside the ellipse. So they'd fall inside your oval. Okay, so two types of questions on ellipse. Graph, find all the stuff, and then here's the information, give the equation. So the graph of this, if I look at A, what do you know just based on looking at this equation? It's vertical because the bigger number is under the y, so it's vertical. What else do you know? Yep. Center is 0, 0. What else do you know?
A is 9, B is 5.
Good. A squared is 81, so A is 9. B squared is 25, so B is 5. So I can graph it based on that, but it's going to also ask for your foci. So I have to do the foci. C squared equals A squared minus B squared. C squared equals A squared, which is 81, minus B squared, which is 25. 56. Yep.
I know this is going ahead by a lot, but how many questions do you think are like on each lesson?
Ooh, I didn't count.
No, but like, do you think it's like?
There's like one graph, one equation, one graph, one equation. So of these, there's one of each, and then there's one that's like the...
The questions like throughout the lessons, like are those like equal?
Pretty much,
Okay.
yeah. You're welcome. And then C would equal the square root of 56. This is 2 and 28, which is 2 and 14, which is 2 and 12. I mean, 2 and 7. Sorry, I don't know what's wrong with my brain this morning. 2 2s brings to the outside. 2 times 7 would be 14. That's going to get left underneath. So that's your C. Yep.
Do we have to put it in our form?
It's going to be in that form.
Or like, can we make it like square root 56?
It's in multiple choice, so it's going to be in that form. Yeah. Okay, so my center's at 0, 0. It's vertical, so we go up and down the A. So the 9 somewhere up here, the other negative 9 somewhere down here. Those would be your vertices. The B is 5. We go right and left the 5. And then I'm going to make my curve as best I can. It's actually going to give you a blank graph. If you want to draw it out, then it gives you the multiple choice. So I would say start with the easy stuff first. Is it vertical? Narrow it down, because I guarantee some of your answer choices are going to be horizontal. And then your foci is up and down. Now square root 56 is it's in between 7 and 8. So it's going to be somewhere in between 7 and 8. But on the answer choice, like it will say, and it was up and down, so it would be 0, negative 2 root 14, and 0, positive 2 root 14. So there might be two graphs that are identical, and then the focus is the difference. Or you might get lucky, and just the graph is going to be different. If there was something with the x, it would be a shift off the center there. If there was something with the y, there'd be a shift off the center there.
If it was like x squared minus 4 with the center.
It would be x minus 4 in parentheses squared, and then it would be positive 4.
Oh.
Yep. Yeah.
Is there really something for the x?
No. I mean, when we get to standard form, we're gonna do complete the square in a minute. That's where it would be. But now, no. Okay, then it says find the equation of the ellipse. Now you're given the information and you've got to work your way backwards. Again, we will give you the graph paper because I think it's going to be helpful for stuff like this. But if I wanted to graph I would start with vertices at 0, 7 and 0, negative 7. Those are your vertices. And foci at 0, 4 and 0, negative 4. So what do I already know about this guy? It's vertical, which means the y gets the a. What else do we know? Where would the center be? Good, 0, 0. Halfway between either of those points. So I could go halfway between the vertices or halfway between the foci for the center. Now from the center to the focus is what? 4, and that would be your C. And from the center to the vertex is 7, and that would be your A. Valeska. The what? That's the focus here. Yeah. So again, because it's multiple choice, I would start before I even get to B and see if I can get an answer without having to do extra work. I know it's a y squared over 49 plus an x squared over something I don't know equals 1. You might already be able to narrow it down. Maybe you get lucky and they're all the way narrowed down, but at least narrow it down halfway. And now all we need is the B. So C squared equals A squared minus B squared. So 4 squared, which would be 16, would equal 7 squared, which is 49, minus B squared. Subtract the 49. Negative B squared equals negative 33. So B squared equals 33. All right, then came hyperbolas. Actually, let me. All right, so hyperbolas are those parabola shaped, right? And they point out in either direction. Just like with ellipses, they are vertical or horizontal. This time the order matters. The A is the denominator that comes first. So order matters here. I know it's an ellipse. I'm in a hyperbola because of the minus in between. So the ellipse has the plus, the hyperbola has a minus. So if the A is under the X, which means the X would be first, then this is horizontal. My branches point outward. Yes. And then remember you have your asymptotes here. If it's horizontal, my asymptote equations are y equals k plus or minus b over a times x minus h. Right under it. If it is vertical, and I would know that because the A is under the Y or the Y is first, then my branches point up and down with the asymptotes running through them. And the asymptotes here are the opposite of this fraction, or the reciprocal of that fraction. That's the only thing that changes. plus and minus a over b, x minus h. Everything else is the same, but the a over b flips. And then the relationship between a, b, and c for a hyperbola is a squared plus b squared. God bless you. All of the stuff about an ellipse and ABC is true for a hyperbola. HK is your center. A is the distance from the center to the vertices. B is the distance from the center to the co-vertices. C is the distance from the center to the foci. Questions on that one? Okay, so now it says graph the hyperbola, find the center of the vertices, foci, and asymptotes. So if I look at my equation, what can you tell me just by looking at it? It's horizontal.
Wait, wouldn't it be vertical?
Because the x comes first, right? Bigger doesn't matter. It's what's first. Yep. What's your center?
1,4.
Good. What's your a squared? 25, so a is 5. What's your b squared? 81, so b is 9. Then I would go to the graph and see if I could narrow it down. Center at 1, 4. A is the distance from the center to the vertices, and that's going horizontal, so right and left. So I'm going to go right 5, and I'm going to go left 5, and those are my vertices. I go up 9 and down 9, and those are your co-vertices. And we make that little box. I probably should have given you smaller numbers, but you get the idea. Find the corners of your box. Draw your asymptotes through those corners. And it's horizontal. So my branches point right and left. On this one, yeah, because it's a horizontal one. It would flip-flop if it was vertical. So if I could already narrow down my graph, I obviously would, because I don't have to do any extra work now, but it's going to ask for your asymptotes. So if there were two graphs the same, that might be the difference maker. And it's y equals k plus and minus, because it's horizontal, b over a, x minus h. So it'd be y equals, the k is 4, plus and minus, the b is 9, the a is 5, x minus h, which is 1. The foci, I need my c for. So c squared equals a squared plus b squared. C squared equals 81 plus 25. Actually, I just reversed that. Let me reverse it. 25 plus 81. C squared equals 106. C would equal the square root of 106. That's 2 and 53, which doesn't go any further. It's on the major axis, which is horizontal. So my foci, I'm going to take that 106 and add and subtract it to the x coordinate of my center. Because it goes on this axis. So you got to move it to the right that many and to the left that many. So it would technically be 10-ish, 10.2 maybe, from my center. So I'd go to the right 10, I'd go to left 10. That one's not graphed on the graph though. So it's going to give it to you like above the graph. It's going to give you the asymptote and the foci. But it's not actually plotted on the graph. The ellipse one is plotted on the graph. All right, then we reverse it. The equation of the hyperbola. Vertices at 4, 0, and negative 4, 0. And foci at 7, 0, and negative 7, 0. So what do we know about this guy already? A is 4. C is 7. It's horizontal. And center is 0, 0. Because it's halfway between any of those, any pairing. So because it's horizontal, the X is going to come first. I already know the A is 4, so the X is going to go over 16. All I got to find is the B. C squared equals A squared plus B squared. So 49 equals 16 plus B squared. Subtract the 16. B squared is 33. I don't even have to graph the rest of it. Questions? All right, and then the last one. You need me to go back? No? Okay. This guy. What do we have to do here? You gotta group them and complete the square. So you have to actually put this in a standard form, right? So I'm gonna group the x's. So 9x squared minus 54x. I'm gonna group the y's, 4y squared minus 8y. And I'm gonna bump the constant to the other side. If there's something on the squared term, we got to take it out. So I'm going to divide by 9 here, and I get x squared minus 6x. Something on the y squared, I got to take it out. So I'm going to take out the 4, y squared minus 2y. Don't forget to take it off of both terms. Still equals 59. Now to complete the square, we take that second term, we divide it by 2, and then we square it. So 6 divided by 2 is 3. 3 squared is 9. I add it inside the parentheses. And I have to add it to the other side. But if I took out something, I have to multiply it by it first. So I'm adding 81. Now I repeat that process for the y. 2 divided by 2 is 1. 1 squared is 1. I add it there. I'd add it to the other side, but I got to multiply by 4 first. I factor each of those perfect squares. So the number stays on the front. Square root the first term. Square root the last term. Take the sign from the middle, put it in parentheses and square it. Plus 4. Square root the first term, square root the last term, put the minus between them, put them in parentheses, and square them. And this is 85 plus 59, which is 144.
And then wouldn't you add 4 to 59 plus?
I actually have to divide. So now I got to get it equal to 1. I'm going to divide everything by 144. 16, right? Yep. So I would say for this for this assignment, which is not due till Tuesday, just go back and finish the ones that we didn't finish. Get yourself some extra practice, submit this homework. I'm going to publish the full packet, but you have a full week next week. So if you want to take a little bit of a brain break, if you're feeling pretty confident, you don't need to slam it all in, feel free to do so. If you want to get started on it a little bit, then go through the packet. Maybe spot all the ones we've already done. Spot the ones that are parabolas, ellipses, hyperbolas, and all the asymptotes. I think those are at the beginning. And work on those because they're fresh, okay? We are going to spend time next week reviewing the individual stuff as we keep moving. So we'll go into the trig stuff, we'll go like all that stuff, and we'll keep reviewing, and you'll get an opportunity to work on your packet as well, okay? Especially